All right. Thank you, everyone, for being here. I'm going to be talking today about SCANOSS. We are a company based in Madrid, and we have a software composition analysis platform which is entirely open source. If you wonder about the Frankenstein, I left some brochures, and you've seen the Frankie in our booth here outside. When we code today, we put a Frankenstein together. We take bits and pieces from the open source community, and that's our Frankie. And since we are a software composition analysis tool, we help you know your Frankie. We help you know your software composition. I've been talking today about license compliance with AI-assisted coding, because this is quite topical these days. Companies are really worried about developers using ChatGPT or any of these tools to code. So what happens with the compliance? So that's what I'm going to be talking to you today. You'll see some graphics that are auto-generated by AI. I have the prompts in the bottom. And I'll start by saying that AI's ban, like witchcraft in the Middle Ages, is fueled by fear. Right? I mean, we're afraid of something, so we immediately ban it. But this is something that already happened. If you are old enough, like me, to have experienced the beginnings of open source, you've seen that open source started with an exponential adoption that got to a point of disruption, and then started bothering the proprietary software business models. So companies started to ban open sourcing companies. And then all the lobbying in the public and private policies against open source. You remember Microsoft saying that open source was the cancer of software. Yet a few years later, they acquired GitHub, because from the banning, we went into corporate adoption. Companies realized that if you don't use open source, you have a disadvantage, because those who do have a competitive advantage. They already have their building blocks. So then it comes the corporate adoption, all the processes to make sure that the company is complying with these open source licenses and the security and all the tools and the products and so on. And then when that matures enough, companies start to worry about compliance and about these challenges, and then we end up with standardization. We have an ISO today, the 5230, governments requesting software bill of materials, meaning visibility on software composition, and SBOM standards and package URL and so on. So in the world of AI, we are in the point of disruption and banning, right? That's what we are today. But it's going to be, at some point, adopted and standardized, because companies who don't use AI have a disadvantage, same as with the open source 20 or 25 years ago. Today, we see that the open source adoption increases. There are many different reports and research everybody points at about 90% of our software is open source. Governments realize that and start to demand software bill of materials, because the risks associated with open source have to be managed. And I'm not saying that open source is a bad thing. It's a good thing, but just like any third-party code needs to be managed in a company or in a government agency. And now we have all these AI-assisted coding tools. So that makes the third-party integration, third-party software integration almost involuntary, because you don't know. You're using an AI tool to code, and you don't really know if it is bringing known open source or not. So that's a problem. Is there any attorney in the room? That one I know. Anyone else? Okay. I am not a lawyer, and just in case, full disclosure on that, so I'm going to be making some statements that touch upon about law, and I want you to stop me and give me your opinion if you think I'm saying something that is not right. So developers who don't use AI are being eclipsed by those who do. We know that, because you get this, AI gives you this brain extension. You never start from scratch. It's easy to find answers. So we know that. And there are two challenges with dealing with external code. First of all, we enforce software licenses with laws made for human expression. That is a challenge because programming language has bigger building blocks. You have only a limited set of instructions in a programming language, while we have thousands of words in the language we speak. So that is a challenge. Yet the laws we use are made for human content and not open source. So in this world where you have this infinite amount of monkeys typing in a keyboard, then it would be a lot more likely for them to generate code if they're typing words from an existing programming language than words in any human language. So the possibilities of generating AI existing material are higher with software than with texts. And the second challenge is that humans we learn from copyrighted code, and so do computers. So it's the same thing. We read a book that was written by someone, and then we get inspired. We learn from that. And machines is exactly the same thing. And in history, every musician, writer, or painter was inspired by an earlier musician, writer, or painter. So always we take existing copyrighted material to learn. And that doesn't mean that the code we generate or the painting we make is infringing anyone's copyright, unless we're copying and pasting, right? So that is a problem. Now, do you believe that because of this, maybe courts will relax towards AI-generated code, just because it's something that I don't know and I didn't know that I made a mistake? The answer is basically no, because it's existing copyright law and jurisprudence what will prevail. And not because I didn't know means that I can get away with it. So now we have a problem that we are introducing maybe someone else's code and we don't know about it. We still must fulfill those license conditions, Alberto, right? So that's the challenge. And where is the problem? Well, again, if we learn C programming, for example, any C programmer here, I'm sure you read Dennis Ritchie's book. And then, does that mean that every line of code you write belongs to Dennis Ritchie? I mean, no. Of course, he deserves a lot of credit for everything he's done. But as long as you're not copying and pasting, then there is no problem. Then it's your code. So is this, on the dark side, you have this verbatim copy. I copy and paste. That is wrong, of course, because then you are taking someone else's work, and then you cannot take the ownership on that. You have to fulfill the conditions under which that code was published. But then you have the inspiration on the bright side, which is I'm being inspired. I read Dennis Ritchie's book, and I wrote C code based on my learnings from the book. That's totally fine. Then you have, well, I take something from the internet, change the variable names, hoping to make it look a little bit different, and then off you go. Well, that is on the really dark side. And then I used ChatGPT, and it generated something that doesn't match anybody's code. It wasn't me doing it, it was ChatGPT, but it's not matching anything. Then it's on the bright side of the scope, and then everything in between. So that problem existed long before AI and will continue to exist. Now you will say, okay, but then ChatGPT knows how to code. ChatGPT will not copy and paste, right? Well, it does copy and paste a lot, actually. If you're asking for something that is very popular, like, I don't know, write a loop to come from 1 to 10, I mean, it will be very unlikely that it will match anybody's code. But if you ask for something specific, like one of our programmers asking for the winnowing algorithm in C, It took 11 regenerations, right? Because in the first one, there are plenty of winnowing algorithm implementations in GitHub, for example. We use that algorithm to hash snippets. After 10 regenerations, it came up with this, which is a verbatim copy of our winnowing algorithm in GitHub. So on the left side, you see the ChatGPT's generated code, and this is our code in GitHub. Now pay attention to this. Hashing the hash will result in a better balance resulting. This is what ChatGPT commented. It changed a little bit here if you added some asterisks here. So but this in courts will have no chance. I mean, this is clearly a comment from a developer. It's clearly evidence that this is a verbatim copy. So Alberto, I think that this will not stand any chance, right? And maybe in this case, the code is very simple, but this gives you a clear evidence that this is copied and pasted. So OpenAI claims that they have the means to prevent that the output equals the input, but clearly it is not the case. And if you're using the same tool, if they are using their own algorithms to detect that, that is wrong. You have to use something different that makes a cross-check, right? So what we have is this massive knowledge base with all open source, and we have about 3 trillion lines of code in the knowledge base. We're able to find these similarities. So identifying undeclared components is key to a complete SBOM. We have today this false sense of achievement by believing that, okay, I have an SBOM, so I'm done. And it is not the case. You have many tools that produce an SBOM. SBOM as a software bill of materials, if you're familiar with the term, is an inventory of software components. If you use many tools today that actually look at your known dependencies, your POM XML, package JSON, your requirements.txt, any log files, any indication of existence of dependencies. That is a component-level software bill of materials. And that tells you the things that you know you're using, or at least that they are declared in the code itself in some shape or form. But that code generated by ChatGPT, which equals someone else's code in GitHub, or that piece of code that you copied and pasted from Stack Overflow, which is a copyleft license, that's CC by attribution, or any file, or if you're coding C or C++, maybe there's no such thing as a component. There's no package manager in that case. Your dependencies are subdirectories with entire components taken from GitHub, for example. These tools, all these cases, totally run under the radar of tools that look at components from your package managers or dependency files. So having a complete picture is crucial to having a complete SBOM. And the risks go beyond license compliance. There are many other risks associated with that, like, for example, your vulnerabilities. You know, you cannot comply with or protect what you cannot see. So if you don't know you're using this component, you will not know if you're vulnerable, if there is a vulnerability in the future. There is also trade compliance regulations. You need to know the list of cryptographic algorithms and their strengths to do a proper export control classification. And if you don't know which components you're using, I mean, your cryptographic algorithms will come from your open source. If 90% is open source, then most of it comes from your open source. In fact, when it comes to cryptography, if there is anyone with the skills here, rule number 1 is do not implement your own cryptography, right? So maybe 100% of the cryptographic algorithms come from the open source. And then, you know, the quality of the code, the obsolescence. Are you using a component that hasn't been maintained in 5 years, while there is one that has several pull requests a week? Then comes another, which is quantum safety. Is your product quantum safe? Companies start to worry about this. And what is the input to that? Well, the cryptographic algorithms you're using, right? It's the same use case, the same need, the same input as export control. There could be other risks that we don't know yet, just like quantum safety was not a concern a few years ago. But it all boils down to knowing your software composition. You need to know what you've got, declared and undeclared. So about SCANOSS, we are a software composition analysis tool that we sell our data, basically. So we offer this as data. All the software we make is open source to facilitate access to this data. And we have, since our focus is the data, we have the biggest knowledge base in the market. There are other commercial tools that do similar job, but we see a lot more. And that data is offered also for free. Otherwise, our open source will not really get a lot of adoption. If you make open source that depends on proprietary data, and that data is only available to paid or customers or evaluations, then the open source will not be interesting. But we launched the foundation a few years ago, and there are many companies and universities behind this foundation, and the foundation provides a free API that powers all the open source we make. So we have this automated license compliance validation tool. You can use this in an audit mode, like an episodic audit before you deliver something to your customers. You want to know if everything is okay. Or you can connect to your CI/CD pipelines and create an issue every time there is new open source introduced that is not declared in your SBOM. So we know open source, we use open source, and we are open source. And we have two sets of APIs, because since we are a database, we are an API. And we have one set of APIs allow you to detect your open source. So basically, you calculate your fingerprints, you throw them to the API, and it comes back with matches. We tell you, your code is not sent to the API. It's just you calculate fingerprints using an open source algorithm, just like everything we do. And then we tell you, we compare that against this massive knowledge base, and we tell you what we see. So, and we, of course, we also look at your dependency files and so on, so we get the complete declared plus undeclared software bill of materials. So we take software, and we give you an SBOM. And then the other set of APIs take an SBOM and gives you open source intelligence. So, for example, here's my SBOM, and I want to know all the cryptographic algorithms I'm using, or I want to know all the vulnerabilities existing for these components and versions. Since we're open source, we sponsor a number of foundations like the Eclipse Foundation and the Linux Foundation and the Software Heritage. We're part of the software-defined vehicle group, and we give speeches and as many events as we can. And since we are open source, and we have this foundation providing free access to that data, an ecosystem built quickly around our tool. There are other open source SCA tools. We are the only open source SCA tool that has this database behind that can identify snippets, but you see array there. You know, these open source tools like Fossology or Fosslight or ORT make detection of what is declared. Like ORT looks at your dependency files, Fossology looks at your license files and license headers. And they make this identification of open source components based on what is declared. Now, these three tools, and Fosslight is developed by LG in South Korea. It's very popular in Korea, and it's something similar to Fossology, I would say. These three tools now natively integrate with SCANOSS. So now all these three tools gain that visibility of the undeclared. Now, Fossology, for example, can detect the license of a file that doesn't have a license header. It runs Monk to detect the license header. There is no license header. I don't know anything about it. Then I throw it to SCANOSS, and I see what they know about it. And then it comes back with a license and a component and a bunch of information. There are commercial SCA tools. There's only one that I can mention, which is TrustSource here in Germany. There are others that I cannot mention, but have access to our knowledge base to have snippet-level visibility. And then there are universities, auditing firms like Array using the technology. And we've been tested in Italian courts, and that was Array behind that first GPL case in Italy. The evidence was gathered using SCANOSS. So with this, we solve this problem. The other tools, commercial tools in the market, have their databases and provide this detection that is not really compatible with anything else. And you used tool 1 has one data set, tool B has another data set, and you're not really comparing apples to apples. But if you scan with SCANOSS or Fossology or Fosslight or ORT, you get to the same result set. And if you use any of the other commercial tools, you also get to the same result set. So we solved this problem. We made this bar that measures. As a first open source solution, we are a de facto standard. And this brings, there's a negative side for corporations that are not using SCANOSS, because if you're using any of these other tools, you cannot see what anyone in the community can see. See how this works? So I'm using tool X, and I'm scanning with tool X, and anyone using Fossology will see, leave aside the fact that our knowledge base is much bigger, just for being different, will be a different, and then the chances of not seeing something are going to be there. So it's important to use SCANOSS. SCANOSS is absolutely free, so anyone can do this for free. We are built for integration. So since we are data, of course, we are an API, and since we're an API, it's very easy to integrate. So we have built SDKs, so you don't need to code. It's easier to integrate in your applications. And if you don't need to code, we also build CLIs on top of this SDK, so you can use a CLI from the console. In that cheat sheet I left in your tables, you can see how easy it is to install and use SCANOSS. We have pipeline integrations, webhooks, and then graphical interfaces and IDE integrations. Of course, we use SPDX and CycloneDX as the SBOM standards, and then you can export JSON, HTML, CSV if you need file-level information. And we use package URL as the main identifier, and this is something that is, most open source tools today use package URL. It's an effective naming convention for open source package versions in specific repos. It's that barcode you have in the food. There is finally a way to identify components, and this is important because then our SBOM with package URLs becomes actionable. You can decorate that data using other systems. By being open source, we have this benefit of being safer because there's no secrets on how your data is being handled. If you scan your code, you don't need to trust me telling you we are just calculating hashes and sending those hashes to the API, because you can see what's going on because we are open source. That's a big advantage. And then since we don't sell software licenses, there is no vendor lock-in mechanisms. Problem with our, as we call legacy competitors or legacy SCA platforms, is that they sell licenses to their proprietary software, and they want to make it as difficult as possible for you to switch to the next tool when the contract expires. We don't have that. All the software is open source, and what we provide you is with data, and data that is actionable. And since our focus is the knowledge base, we have the biggest knowledge base in the market, most accurate, most complete. So, bottom line, accurate, standardized detection of code plagiarism is adopted by other open source communities and SCA suppliers and validated in European courts. Here is an example. I have little time. I only have 10 minutes left, and I want to leave some room for questions, so I'll speed up. So this is basically a piece of code. This is what the hashes look like, the fingerprints. Technically speaking, MD5 hash and CRC32C checksums. This is sent to the API, and this is what comes back. A bunch of information, and this is entirely free. This is the output of the free API. If you want to try this for yourselves, you have this in your cheat sheets, but you can pip3 install SCANOSS, and then you just SCANOSS pi scan a directory. You don't need a username, password, API keys. You don't need to register nothing. The Software Transparency Foundation provides this API, which is free and anonymous to everyone. There is also a JavaScript CLI. Everything is open source, so this is where you can find our code. There is also a UI. The UI is also open source, like everything we do, and you can download it from scanoss.com. If you don't want to build it, then you have pre-built packages for Windows, Mac OS, or Linux. You get a graphical interface, you point to a directory, start scanning, then you get all the results, and you go through the directory tree, and you see what's in there. And our UI and our CLIs, everything points by default to this API endpoint, which is what I was mentioning, which is the Software Transparency Foundation. So nobody needs to pay a dime to use our open source. However, when companies need a guaranteed instance with guaranteed throughput, guaranteed availability, the SLA, the whole bit, then that is when they come to SCANOSS to get their dedicated SaaS or on-premise installation of the whole knowledge base. But anyone can really use this as open source and with that free API. Bottom line, and I have a few minutes left, hopefully 9 minutes left. Embrace AI-assisted development. We believe that this is the future and there is no need to ban it. If you have the means to guarantee compliance, you can validate your software composition with SCANOSS. This is free and open source to everyone, and this is foundational to all angles of open source risk. We have 9 minutes left for questions. Yes. Here's the microphone. Hold on. There you go.
In the end, I think we both agree that it all boils down to does the learning source of the AI match with your knowledge base? Mm-hmm. Is there a way to make sure that both match? I don't know whether ChatGPT, yes, I think ChatGPT does say what it learns on. Do we have a concrete way to make sure when we use any AI which declares its learning scope, but to make sure that it matches with SCANOSS source base with
as far as I know, only Code Whisperer by Amazon provides you with citation and the licenses of the snippets it is actually bringing. That's the only thing, the only tool, as far as I know. But regardless of whether it is Code Whisperer or any other tool, you can scan your code and you can find. We will tell you where it comes from, the license, and all the information we know about that.
No, I meant to make sure. I meant when you look at all the learning base of ChatGPT, mm-hmm. For example, I take ChatGPT as an example. Let's say it scans GitHub repository A, B, C. Mm-hmm. Make sure, okay, repositories A, B, C are also in the knowledge source of SCANOSS. Is there a way to match, to check whether the sources match from a scope perspective? I mean,
you mean the code generated by ChatGPT?
No, the code on which it learned.
Oh, okay. We don't know where it learned from. We know that it just took all GitHub and it took everything that is open source there. But they don't really give you, OpenAI doesn't tell you if something is coming from somewhere else. So it's not providing with the citation. And if you ask, where does this I mean, you can, it tells you.
So you have to check
everything. Well, you know, the problem of using AI is that it might bring open source without you knowing. But you also may copy and paste from Stack Overflow, or your neighbor maybe did it, or maybe a developer that left the company 2 years ago. So at the end of the day, the tool that you need to use to validate if OpenAI or AI is bringing known open source is the same as everything else. Basically, you scan the code and you compare that code with known open source. And if there is any known open source, you will get to know. So we cannot tell you if something was generated by ChatGPT or not. We only can tell you if the code contains open source. And then we tell you where it comes from.
Yes, with your knowledge base.
Yeah, exactly.
And the knowledge base, I think probably the knowledge base is announced by the Software Transparency Foundation.
The Software Transparency Foundation has a copy, but SCANOSS provides the foundation with a copy of the knowledge base, and we update it often so that it's kept up to date. But the mining and discovery of all this is done by SCANOSS. This is what we do. I mean, every time there is a new version, we know about it, and then we download it. There's a new component, we know about it, and we get it in the list of things to check for new versions. So that's what we do for a living. Here.
So when I was in university, we were threatened with advanced plagiarism checkers, which would compare ASTs. Even if you rename the variables, it would get it right. Yes. And I think taking that a step further today, IntelliJ lets you convert a Java class automatically into Kotlin. Mm-hmm. How language specific are you, and how well can you defend against those more egregious examples? We are language agnostic. What we do is basically natural language processing. We take the input as text, we normalize that, hash, and store in the knowledge base. So this is absolutely language agnostic. So you can match a JavaScript code with Kotlin or anything else that resembles, the same logic. If you change it enough, at some point it stops matching, right? But the algorithm we use, which is winnowing, is quite resilient to change. You can change variable names, and the chances of that hashes changing are pretty slim. And actually, back to the origins of winnowing, it originated in university environments for plagiarism check. So that's where it comes from. So then, of course, the follow-up is, what are the risks of a false positive? You have false positives and you have false negatives. You cannot, that's the nature of it. False positives are pretty slim. But you have to define false positive, right? False positive could be something that it says, here is your code, and here's the other code, and it doesn't match at all, because you're matching hashes, and then that is almost zero. Because the chances of collision between hashes exist, but the chances of 2 and 3 and 4 and 5 consecutive hashes colliding is almost impossible. False positive sometimes is what we refer to. I'm telling you that this comes from zlib, but it's actually a Linux kernel flavor. It is zlib because that's what's in there, but without the context, there are many right answers to where does this file come from. If we don't have context, then we point at the oldest known, which will be zlib in that case. But if you're using a flavor of Android that contains the kernel, that contains zlib, then you have that declared, that is what we're going to point at. So we use the context of your software bill of materials to narrow down and eliminate false positives.
Thank you. First, thank you for the presentation. It was really clear.
Thank you.
I wanted to ask you, we did an experiment for SBOMs in Maven project, and we really struggled with defining what would be the ground truth to evaluate a tool like yours. In your case, how do you define the ground truth instead of the results of your tool? When you want to evaluate how good was the SBOM that you produced, how do you decide if it was correct or not?
I hear from our customers who have access to other tools that what we usually hear is that they discover lots of false negatives in the other tools because they see things with SCANOSS that they don't see with the other tools. So since we have the biggest knowledge base, that happens quite often. If we ever, I am not aware of the case where someone used another tool and saw something that we don't have. If we do find that, then we immediately correct the issue by adding whatever is missing to the tool. But there is no way actually to know if we're missing anything. So effectiveness, you can only compare existing tools and get your conclusions. But the world of open source is bigger than what we have in the knowledge base. So, we can have maybe 99.999, but that project that someone released yesterday, maybe we'll have it tomorrow. We have cycles that run daily for most known open source, but there is also a monthly cycle. So if there is a new project that's not there, maybe you could be a few days off. So we know that we will always have false negatives right? But we do everything we can to have everything as quick as possible into the knowledge base, because that is actually what we excel at.
Okay, thank you.
No problem. I think we're out of time. Any more questions, maybe? Yes.
Yes, about false positives, I've had experiences with false positive, especially regarding some common news patterns such as generated code by EMF. Is there a way to?
Yes.
Is there a way to, in the future, maybe, or is there a plan to say, okay, this pattern is a false positive, and to let other people using the same, which encounter the same pattern, know that this is a false positive because it's a normal usage?
Oh yeah, you have tons of common code structures, auto-generated by IDEs, for example, or common data structures like the list of the months of the year, that array in French, for example, that's everywhere. And we do have a blob of known snippet IDs for which nobody can claim authorship. We keep adding that. Indeed, that's open source. We have that in GitHub. That blob grows. Every time someone says, hey, you're detecting this, but this is actually something that nobody can claim. It's like, I don't know, the list of the results of the logarithm that calculates the CRC32, for example, list of numbers. You have that. It's quite common. We have most of them, at least the ones that we know of, in that blob of ignored snippet IDs. But if you discover anything, you can contribute that with a pull request, or you can just send us an email and then we'll add it. Thing is, it's open source, so now it's not just one company working on this. We get contributions from the open source world. We have here Koki Hama, who contributed the translation to Japanese, for example. Just to point at one contribution that is very close. It's the closest I have here in the room. But we see this all the time. So it's now finally a community working towards we have Yata here with the contribution of an Eclipse plugin for SCANOSS. So you can, from within Eclipse, find if you have any. You can scan from the plugin itself, and then find if you have open source that you don't know about. So that's the beauty of open source. Any more questions? All right. Thank you very much. Thank you.